Welcome to Lesson 3, Video 1 for Redox Reactions for Chemistry 2. Today we're going to learn about another way to balance redox equations, and this is called the half reaction method. And we're going to divide it up into two categories. The first one is if we have an acidic solution. So that means that there is an acid present when we have this reaction. So we are going to look at this in a series of steps, and I'm going to go really slowly through these steps to describe what we're doing, but when you actually do these problems, it doesn't require you to write out each step like this. So the first thing that we're going to do when we're given an equation like this, you can see that we have acidic right here. So the first thing that we are going to do is we're going to divide the reaction into two half reactions. So if we look up here, we're going to divide it into two half reactions where we have the same elements in each half reaction. So for this one, we're going to have Cr2O7 minus 2 yields Cr plus 3, and we're going to have NO2 minus yields NO3 minus. So there are our two half reactions. Our second step, we're going to balance elements other than H and O in each half reaction. So if we look at Cr2O7 minus 2 yields Cr plus 3, we're going to balance this for the CRs. So we have two CRs on this side, so I'm going to put a 2 right there. So we have two CRs on each side. I'm going to do the same thing for our second half reaction. And if we look at this, we can see that we have one N on each side. So we're not balancing for our O's. Our third step, we are going to balance oxygen by adding H2O to the side that needs it. So we're going to balance oxygen by adding water. Water contains an oxygen. So if we look at this half reaction, we have 7 O's on this side. So we need to get 7 O's on this side, so I'm going to add 7 H2O. And then I'm going to do the same for this half reaction. I have 2 oxygens on this side. I have 3 oxygens on this side, so I'm going to add an H2O to the reactants to balance out our O's. Now our O's are balanced, but we've added H's in here, so that's going to be our next step. Balance H by adding H plus to the side that needs it. And this is where that acidic comes from. H plus we know is our acid. So if I pull down this half reaction as written so far, and I balance it for H's. I don't have any H's on the reactant side, but on the product side I have 14. So I have to add 14 H plus to this side. For our other half reaction, I have 2 waters on this side, or 2 hydrogens from water on this side, so I need 2 H plus on the product side. So now all of our elements should be balanced. And we come to our last balancing part, and that is we have to worry about the charge. Because remember, with redox, we have to worry about all those electrons and charges. So we are going to add electrons to the side that needs it to balance the charge. And this is probably the trickiest part. So if I look at our first half reaction, and again, you don't have to write this out each time. If I look at this half reaction, and I use our arrow here as a separation point, and I calculate what charge we have on each side, we have to make sure that they get equal. So I have plus 14 and a minus 2. So this side is plus 12. This side we have 2 Cr plus 3s and a neutral water. So this side is plus 6. Our goal is to get these to be the same number. So if we add electrons to a side, we have to make it more, adding electrons makes it more negative. So whichever one is the highest positive charge is the one that we add electrons to. So we have to add electrons to this side, and that is going to be 6. So if we add 6 electrons, that becomes plus 6, and it balances this side. On this half reaction, on the reactant side, we have a -1 total. So water is 0, and O2 minus is -1. Over here, we have 2 H pluses and a negative nitrate. So this one is +1. So we are going to add 2 electrons to the product side, and that is going to make that -1, so our charges will balance. A little hint here, when you're doing these, your electrons have to be on opposite sides of our 2 half reactions. So with this, our next step, multiply each half reaction by a whole number, and we want to find the LCM for electrons. So if we look, we have 6 electrons and 2 electrons. Our LCM is 6. So we have to multiply this half reaction by a whole number to give us 6, and this half reaction by a whole number to give us 6. This one's going to be times 1. That one's going to be times 3. So that leads us to our last step, combine and cancel. So we use our arrow. So we're going to take both of the reactant side, multiply them by our whole number, and then combine them together. So this side of the half reaction we multiply by 1. So we're going to have 6 electrons plus 14 H plus Cr2O7 minus 2. And then we're going to take the reactant side over here, but we have to multiply all of our coefficients by 3. So we get plus 3H2O plus 3NO2 minus. I'm going to do the same thing with the product side of both reactions. So this side over here is 2Cr plus 3 plus 7H2O. And then we have to multiply the product side on this half reaction by 3. So 3NO3 minus plus 6H plus 6 electrons. So that's the first part of this step. Now we cancel out everything. And the first thing that we can see that cancels out, so they have to be exactly the same substance on both sides with the same charge. The coefficients are what we're going to get rid of, basically. But if we look, our electrons should cancel out completely. So we have 6 electrons on both sides, so those cancel out. If they don't cancel out and you have electrons left over, you made a mistake. Electrons always have to cancel out. That's the whole point of this. So if we look, we have H plus on both sides. We have 14 on this side and 6 on this side. So I can take away 6 from both sides, and that gives us 8 now on this side. The only other thing that crosses out is water. We have 3 on this side and 7 on this side, so I can cancel out 3 from both sides, and that leaves us with 4. So nothing else is going to cancel out, so now we have our final equation. 8H plus Cr2O7 minus 2 plus 3NO2 minus yields 2Cr plus 3 plus 4H2O plus 3NO3 minus. And that is our final answer.